It's great news. And then moving forward, we're going to have Springett, who is a hydrologist.
Which one was it, Alan?
All right. Thank you for being patient. If you do need to get up and get the blood flowing in some of the other regions, feel free. Okay, when I was asked to do this, they just sort of threw a couple of things out. One of the things that they wanted to get some information on was some recent activity by the Environmental Protection Agency. Now, I happen to work for a federal agency, and so it helps a little bit to understand what federal agencies are. As my agency, the EPA, is under the executive branch of government, under the President of the United States. And as all agencies in the United States, they are sensitive to political winds in both directions. And that's something very important for all of us to remember. It can blow both ways. And we have to help that wind blow from the other way as well. So what we have here, and you can kick to the next one, going to be covering a little bit of a background about the EPA's study of hydraulic fracturing. And then we're going to go into a little bit on climate change, because that sets the stage for some of the other things that the EPA has been doing actually quite recently. A small view of a new complaint that is arising, and I think we can, in this area, we may be able to nip that in the bud perhaps. A quick summary and then questions, which we can go into. So this is the, some of these slides are, this is actually a real condensation of what the EPA put out in February as the final update on their plan to start the study. Some of the work has actually been undergone at this time, but they had one slideshow in November, and then this one in February is the most recent. And actually, I've noticed some differences, and I'll point that out as we go through. Next page. Okay, so they're talking about the water cycle in hydraulic fracturing, and this just is a diagram that they use in there that talks about all the various things that are going on for a well injection, and then what happens under the ground and so forth. Next one. And when we're looking here, this is a map of the lower 48 states and the shale plays. Now these are gas and oil shale plays. And one thing that's really interesting and is impacting the market a great deal right now, if you see down in Texas there, you see something called the Eagle Ford. The Eagle Ford at one time was considered one of the top oil plays in the country. And they were pretty well sure that they'd suck that baby dry. And then someone got the bright idea when they started doing the Barnett and some of these other horizontal wells in hydraulic fracturing, and they said, gosh, I wonder if that helped down there. Well, right now, the Eagle Ford is now thought to be able to produce at least as much oil, gas, and other liquid fractionates as it ever did previously. It's received brand new life. In fact, so much life that the oil and liquid fractionates, which actually have a lot of value right now compared to gas, are so valuable that they've actually filled their pipelines. They can't get any more, and many of these wells are actually flaring all of the gas because they just don't need it. They're just burning it into the air because they want that oil so bad. And this is the case all over the United States. Hydraulic fracturing is not just something for natural gas in New York State or Pennsylvania. Hydraulic fracturing is the new wave of how they are finding oil and gas throughout this country and throughout the world. The reserves are skyrocketing. And this is why. And it's hydraulic fracturing, so it's not just here. Hydraulic fracturing and what comes from this process, this has impact on generations of people throughout the world. Next one, please. So this is the set of research questions they talked about. Water acquisition, mixing of chemicals, well injection, flow back, and then the wastewater treatment and waste disposal. And they have the potential impacts off to the right. Next one. They have requested information from several oil and gas companies, 9 of them, and these are the information they're requesting: quality and quantity of well cement, the extent of their integrity testing of that cement, in fact, identity of products or chemicals used, essentially what's in the fracturing fluids, drinking water resources near the well or through which it passes, extent of baseline water quality monitoring, and source and quality of water being used for these processes. Now, interestingly enough, from what we heard earlier from Mr. Zagata and Sovis, it's obvious that New York State is very good on all of this. Go to the next one. I'm going to try really spinning through this quickly. If you have any real interest in all this stuff, you can go to the EPA's website, type in Marcellus Shale. They have a whole section on it with both their old and new slide sets, which have a lot more slides in them than this. I'm just covering the high points here. But this is what they're going to do. These are the randomly chosen companies. ConocoPhillips, one of the biggest companies in the country, is in there. And they're reviewing that information. They expect approximately 334 well files. Nice. And then they have some case studies. They have 2 different types of studies. They have prospective case studies, 2 of those, and then they have retrospective case studies, which prospective means they're looking at what are the potential impacts going forward. What kind of baseline can we get? And then retrospective, well, if we had a problem in this area, what kinds of other problems have arisen, or has it not been a problem since? Now, if you look at the set of slides from November, it was interesting because they had 1 less retrospective case, and they had 6 total, and half of them, for some amazing reason, all came from the state of Pennsylvania. Now, that to me says that someone is aiming very hard at the Northeast, because there's a whole lot of wells in many other places, and some of them, they know there's a lot more problems. You go into West Virginia, trust me, there's a lot more problems in well drilling there, because they don't pay attention there as much as we do here, and not even as much as they do in Pennsylvania. So this is the studies that they're doing. Next, please. And then these are some of their questions. For wastewater treatment, waste disposal, what are the potential impacts from surface water disposal of treated hydraulic fracturing wastewater or on drinking water treatment facilities? Okay, when you have a drinking water facility and someone dumps something into the water upstream, well, what do you have to do to that to make it drinkable for the consumers? Always amazes me when they do all this kind of testing and they kind of ignore all the hospitals that are dumping all these toxins through their patients into the water in the same way, and it's not being treated. So, next. Surface water transport. Okay, this is essentially, okay, if you've got a pit and it overflows and runs out, well, we know we're not going to have that problem here because they're all going to be contained. But this is something they're going to be checking around the entire country, trying to identify the impacts, potential impacts to drinking water treatment facilities from, okay, the water runs across and it gets into someone's lake, like Oniana's reservoir. Disinfection byproducts, okay? One of the things you have to look at is when you get water, you have to add certain disinfectants to make that water suitable for people to drink. And there are things in surface water that when you add chlorine, it's not a good thing. One of those is algae. Well, if you've got algae in your surface water, the lake up here, and they happen to bring that into the treatment system, they hit it with chlorine, Well, they better have that algae out of there first, because if they don't, they create something called trihalomethanes. Kind of a complex word, but it is a really nasty poison, and it can really mess up your liver and some other organs in the human body. And so you have to watch what are the impacts of the chemicals they add to that water to try and clean it up. And so they're going to be looking at, do any of these chemicals that might be in that water have an impact there? This gives the objective, the approach, and the current status. Okay, next. And then, this is an interesting one, is environmental justice screening. Now, the President of the United States, back in the early 80s, issued an executive order on environmental justice, and every federal agency has to look at this, and it really is supposed to determine whether hydrofracturing occurs more in counties home to predominantly low-income, minority, young, or elderly populations. And, you know, it's interesting how disingenuous they are there. It also applies to racial mixes within communities. We had a project down in Tennessee where they were going to do, they had all these people that were flooded and all their homes were pretty badly messed up. And they wanted to move them all out. And it was a particular group of people who had a fair amount of political power in that area. And we were going to buy hundreds of homes. And then someone said, oh, but if we take all of these people out of this particular voting district, suddenly they don't have a majority in this voting district. So, you know, we can't do that. We have to leave them where they were damaged. So, federal agencies can be forced to do completely idiotic things because of certain other decisions that have been made by some of our political leaders. Again, as Ed noted so succinctly, the one thing that we can do is try to make sure that the people that we have serving us in all of the legislatures and all of the town boards is to ensure that we vote in people that agree with how we believe things should be done, and hopefully that is a method that's a little bit more common sense. Next one. Okay, now, no, back up. Back, there you, now down one. Okay, go in. Okay, so there are, I thought there was another one in there, sorry. Threw this together in a hurry. As we all know, there are people who, and you know, I suppose not too many people here know them, there are people who have really strange ideas about this planet and what goes on. And I chose this as just sort of, this is an example. There are people out there who purely and truly believe that the Earth is flat. That for 500 years, everyone has been living a lie. And they refuse to believe science or the evidence of their own eyes. Because you can take someone up in a plane and you can quite easily see that there's a curve to the Earth. You can take someone up into space and, gosh, you know, we're going around this round ball of Earth, but no, it's flat with the North Pole is in the center and the whole edge is surrounded by ice. And that's, you know, that's the sort of people that you can find out there that believe virtually anything. Next. So, a little bit of background on climate change, and I'll say right here that as a scientist, I believe that the preponderance of the evidence indicates that there is such a thing as climate change and global warming. Now, I'm not going to argue that man is the complete cause, but I think we're probably helping things out a little bit. There are certain things that if you take a laboratory and you put certain gases into an aquarium and you put energy into that, you'll find that it holds energy much better with certain things such as carbon dioxide and methane and the nitrous oxide. So what we have here is the natural carbon cycle with a little bit of addition of fossil fuel burning and land use. And you know, the ocean and vegetation land takes up some, but not all, so that each year we're getting approximately 12 gigatons, and a gigaton's a whole lot. You know, that's 1,000 megatons of carbon dioxide added each year. So, go to the next one. Why is it important? Now, this is an interesting slide. It's really busy, and it's outdated, but it gives one of the best visual depictions that I've seen. You see that big bad boy peach arrow on top? That's carbon dioxide. And in this, it's about 77%, but that's the approximate relative impact of the greenhouse, the three big greenhouse gases, essentially. Carbon dioxide, then you've got methane, and then you've got nitrous oxide. Now, according to this, all methane was about 14% of the total. It's more or less similar, but of that, oil, gas extraction, refining, and processing only came to about 6% of that, 6.3% in that particular year, about 2000. And you know, it's not really increased all that much. So about as much in agriculture as there is in oil and gas worldwide. Not just in this country, worldwide. So, and this is actually way out of date because we're now seeing in the Arctic, we're seeing some signs that we may be having huge additions of methane from natural sources. So, go to the next one. Now, one of the things that's important is to consider how long these gases stay in the atmosphere, and there's no mistake here, actually. Across the bottom, we go from the year 2000 to the year 3000, and at the top you see the nitrous oxide, which goes, EPA claims that it stays in the atmosphere about 120 years. The methane actually stays, they're saying 9 to 15, so I put in about 13 years is a nice average there. But CO2, the CO2 that's in the atmosphere right now will still be there in the year 3012, 1,000 years from now. So when I look at that, I say, okay, methane and nitrous oxide may have a little more impact than carbon dioxide, but in the long run, guess which has the major influence? Carbon dioxide. And that's driving some of the policies at the federal and state levels. In fact, the governor of the state of New York, as well as the President of the United States, have both signed agreements that will limit carbon dioxide production by huge amounts by 2050, supposedly. They're supposed to be dropping carbon dioxide something like 80% of the 2000 level. Next slide. Now, one thing that we see here is when we go back into history and we look at the gases that were in the atmosphere, a couple thousand years ago. This is going back to the year 1000. We can go back actually about 400 to 450,000 years in ice and tell how much carbon dioxide was in the atmosphere. And it was pretty even until, of course, the Industrial Revolution. And then things started really taking off. And I want you to notice something there. The scale on the left has 380 for parts per million, and that was this scale was developed by the Intergovernmental Panel on Climate Change in 2007 when they did their report, and they didn't think it was going to get that much higher than 380. At the time, we were having some people that were saying that there was a major scientist from NASA who was saying it shouldn't go above 350, and he was really concerned about that. Well, when you keep going on the next slide, this shows kind of the impact of temperatures that the IPCC showed in that time, and my laser disappeared, so I'll just point this out. These are 3 different levels that they measured. And it's interesting, this is about where we are latitude-wise. This is the equator, this is where we are. This is 60 degrees latitude, somewhere about the middle of Quebec. And then you can see up in the real polar regions, temperatures were seen to go really high, especially in this high one. Well, it's interesting to know that that high range, you can go to the next slide, actually was well below this figure right here. This is the February 2012 ratings at Mauna Loa, which is the official site that they measure carbon dioxide for the planet. we're up to over 393 parts per million. Remember that 380 I talked about? They didn't think it was going to go much above that. We are blasting well above that. And unless we reduce the total amount of carbon dioxide we're throwing into the atmosphere, those figures you saw, those are probably really small. And you notice that there was a big space. If you go back to that last one, and you can see that high rate, it was going even a lot higher than the middle was from the low. Well, consider that that was run for a lower level of carbon dioxide, and you can move up. That right there. They only figured that we were going to be about 380, and we're way above that. So, continue. Next one. Okay. So, what else is the Environmental Protection Agency been involved with? Well, something that may actually help us a little bit, and that is that last week they proposed some long-delayed rules that limit emissions from all new U.S. Power stations. Essentially what they're saying is you cannot have more than 1,000 pounds of CO2 per megawatt, which is something that was mentioned a little earlier. What wasn't mentioned is that coal averages 1,700 pounds of carbon dioxide per megawatt, while natural gas is down, even without remediation, at 800 pounds per megawatt. And so the fraction of coal is dropping quite sharply. Actually, it was down to about 42% last year, which was down from 50% just a short while before that. And the low price of natural gas effectively has stopped the development of any new gas power generation plants. Everything now is pretty much going into the gas-fired, but we need to do even more. You know, the EPA really needs to be told, you need to extend this rule to existing plants. Because if we put more natural gas plants online, and it's fairly simple and cheap to turn from coal to natural gas, the more natural gas we put out there, the lower the amount of carbon dioxide will significantly lower. Because power plants are one of the big boys when it comes to polluting the atmosphere. And so, using more natural gas would help the whole concept of price in the natural gas industry. It would require that there was more natural gas used in the United States rather than trying to ship it overseas. And it would help reduce the overall use of coal, which, trust me, if you looked at the entire environmental cost of coal, especially with the storage of all the waste, I don't know how many of you remember that dam that blew out and that coal waste went down and took out a couple of communities down in Kentucky a couple of years ago. That stuff's nasty and it stays around forever, just about. A lot worse than anything they ever thought of with gas. Next one. Now, this is interesting. There was an article in the Washington Post by this Brad Plumer, who apparently is trying to say that hydrofracturing and coal can't get along because, gosh, you know, if they ever manage to develop a process for reducing the carbon in coal, which they don't have yet, they think maybe 10 years from now they may be able, and the most viable thought at this time is that they will take that carbon dioxide and they will liquefy it somehow, and guess what? They're going to pump it under the ground and store it down there underneath these shale things. But you know, if you've gone in and gotten your natural gas out, well, you're going to have holes in that thing, and so they can't do that. So I guess if anyone who is anti-natural gas comes to you and you can say, well, gee, you know, we ought to thank those people in the town of Seago and in Cooperstown because they're keeping a section of the county where they can pump that waste in the future. Quite frankly, if I have a natural gas well on my property, I may ask the company, hey, you know, you think you could pump a couple more holes here? I want to make sure they don't want to use this property for storing that stuff. Now, you know, you think it's you know, it is amusing, but carbon dioxide can be pretty blessed dangerous. There was a lake called Lake Nyos in Cameroon, in Africa, and volcano pumped a whole bunch of carbon dioxide into that lake, and the interesting thing, when carbon dioxide comes up from the ground into a lake, it sits there and it pressurizes. And it pressurizes until something gives. And they don't know exactly what happened. It could have been a low pressure event, it could have been a small seismic event. No one really knows, but all of a sudden that carbon dioxide underneath that lake blew out. And from what I hear, the water blew more than 300 feet in the air. And this gas cloud came up out of the lake, and it flowed down through a valley. And it killed virtually every living thing in the valley. Insect, mammal, water buffaloes, people. 1,700 people died from that one explosion of carbon dioxide. So it can be kind of nasty. I mean, you can kind of, if you really hold a grudge, you can always think about, gosh, if that happened in Cooperstown Lake. Next one. So to summarize, the EPA is going to be looking at multiple aspects of potential impacts of hydraulic fracturing on our water supplies. Hopefully they will find that states that use good and reasonable controls, such as New York State, are doing the right thing, and states that are doing the wrong thing, well, maybe they might want to give them a few tips from our state and the state of Pennsylvania to help them along. Carbon dioxide is a major concern in global warming, and this has led to initial regulations that actually, amazingly enough, favor natural gas power generation plants. So all I've got left is questions, and whatever we have. Thank you. Good. Everyone wants to get up and walk around. I can't blame you a bit.